Okay, it's time to practice what we learned about fractions. So here are 8 problems. Why don't you pause the video here, give them a try, and then come back, we'll do them together. Okay, let's get started, and we will look at the very first one. What do we have here? So 7 over 10 plus 2 over 15. Okay. To add these, we need to find a common denominator, right? That's the key here. So let's do a prime factorization of both 10 and 15 to try and find that common denominator. 10 is 2 times 5, and 15 is 3 times 5. Okay, so we can see from the 10, we are missing a factor of 3, and from the 15, we are missing a factor of 2, right? And so that's what we have to add in to make this work. And so if we do that, we're going to get 3 times 10 is 30, 2 times 15 is 30. So our common denominator will be 30. Okay, so let's use that common denominator. This is going to be our least common denominator. So to get that, we have to multiply this by, to get 30, we multiply by 3, so it's going to be 3 over 3. And this will have to multiply by 2 over 2. Okay, so there we go. Let's do this. 3 times 7 is 21, so that's 21 over 30. Plus 2 times 2, that's going to be 4 over 30. Now we can just add these together. So 21 plus 4 is going to be 25 over 30. And we can actually simplify this, right? So 25 over 30, that's the same as 5 times 5 over 5 times 6. And so these common factor of 5 is going to cancel out. And we'll be left with just 5 over 6. Okay, so there we go. That's our answer for the very first one. Let's take a look at problem number 2. So for problem number 2 here, another addition, we have to find a common denominator again. Okay, now in this case, 5 is already a prime number, so there's like no prime factorization to do. 5 is not a factor of 4, so we're just going to use sort of our standard rule here. Let me grab a copy here. Okay, so we're just going to use our standard rule. We're going to multiply the two denominators together to get our common factor. So that's going to be a common factor of 20, right? So that's going to be 4 times 5 here, right? So 5 times 5 over 5, and here it'll be 4 over 4. So that's going to give me a common factor of 20, right? So let's do this. 3 times 5 is going to be 15, so 15 over 20. Plus 4 times 4 is 16 over 20. We add that together. We're just going to get 31 over 20. Okay, there we go. So that's going to be the answer for number 2. Let's take a look at question 3. Okay, so for the third one here, we have subtraction, but subtraction is really processed the same way as addition. So all we need is a common factor. 3 and 5 are already prime numbers, so I'm just going to multiply them together. We'll get a common denominator of 15, right? So, okay, so let's do that. Let's multiply this then by 5 over 5, and this 3 over 3. That'll give us 5 over 15 minus 6 over 15. So we just subtract the numerators. 5 minus 6, well, that's going to be negative 1 over 15. And there we go. Okay, so that's the answer here for number 3. Let's try the next one. All right, for the fourth one here, again, we need to find a common denominator. We can imagine this is 2 over 1, right? So we'll come back to that one. But in the meantime, we have this 6 and this 4. Let's do the prime factorization to find the least common denominator here. So the prime factorization for 6 and for 4. So 6 is going to be, well, that's just 2 times 3, and 4 is 2 times 2, so 2 squared. Okay, so let's look at the 6. What are we missing? Well, we're missing a factor here of 2. So that's what we're going to do. We're going to multiply in another factor of 2, and 4 is missing this factor of 3, right? So we're just going to multiply in a 3. Okay, so when we do that, what do we get? Well, 6 times 2 is 12. 4 times 3 is 12. 12 will be our least common denominator. Okay, so let's grab a copy of this. Actually, you know what? I'll just leave that there. I'll rewrite it. So we're going to have a 2 over 1, that's how I'm going to think of that, plus a 5 over 6 minus a 1 over 4. And so I need to get a common denominator of 12. So in order to do that, I'm going to, well, here I'll multiply this by a 3 over 3. I'll multiply this by a 2 over 2. And don't forget this first one, I'll have to multiply this by a 12 over 12 to get that in a common denominator of 12 as well. Okay, so let's do all the multiplication here. 12 times 2 is going to be 24 over 12. Here we have 5 times 2, that's 10 over 12. And here minus 1 times 3 is 3 over 12. And so now we just have to evaluate the numerator, right? So 24 plus 10, well, that's going to be 34. 34 minus 3 is going to be 31. Okay, so this is 31 over 12. And there we go. Okay, that's going to be the answer for this problem here. Now, when you look at this number, this 31 over 12, some people like to put this in sort of like a mixed fraction form. They don't like it as an improper fraction. I like it. I'm fine with improper fractions, but let's say we want to put this into a mixed form. Well, we have to see how many times does 12 go into 31, right? So 12 times 3 is 36. That's too much. So we're going to stick with 12 times 2, right? So 12 times 2 is 24. And so then 31 minus 24, well, that's going to be 7, right? So we can think of this as 2 and 7 twelfths, right? So that's another way we could think about this answer, but I kind of prefer it as 31 over 12. All right, so let's take a look at the next problem. All right, so for this one, there's actually a few ways we could do it. Let's try it maybe 2 different ways. So the first way I want to look at is we want to distribute this 2/7 into the parentheses. Let's see what we get. Okay, so when we distribute that through, we're going to get a 2/7 times 14 minus a 2/7 times a 7 over 2. Okay, and now we can evaluate these multiplications. Multiplication is easy, right? We can actually cancel some things out, right? So 7 and 14, this will become 1, and that'll become a 2, right? So this becomes 2 times 2 is 4, okay? 4 minus what do we get over here? Well, these 2's cancel and these 7's cancel, so this is all equal to 1, isn't it, right? So this is going to be 4 minus 1, and that equals 3. We're done, okay? This is equal to 3. Let's try and do this a different way. Let's take copy of this and let's think about maybe we will evaluate what's inside the parentheses first, okay? So on the outside here, we'll have a 2/7 multiplied by, well, what do we have here as a common denominator? Common denominator will be 2, right? So I'll have to multiply this 14 by sort of 2 over 2. That makes sense, right? So I'm going to get here a 28 over 2 minus a 7 over 2. Okay, so we can evaluate this. 28 minus 7 is going to be 21. So this will be a 21 over 2 multiplied here by a 2/7. And once again, we can simplify and cancel out a few factors here. So these 2's will cancel out. That'll just give us 1. And this will cancel out. This is a 1. This is a 3. So this, once again, just going to equal 3. And there we go. No surprise, we get the same answer. Let's try the next one. All right, this next one's a little bit more interesting. There's a few ways we could evaluate this. The way I'm going to think about it is I'm going to take this 2 times this entire thing plus 1/6 times this entire thing. Okay, so let me write that down. It's going to be 2 times 1 minus 6 over 11 plus 1/6 times 1 minus 6 over 11. Okay, and then we can simply distribute the 2 into here and the 1/6 into this parentheses. So we'll get a 2 times 1 minus a 2 times 6 over 11 plus a 1/6 times a 1 minus a 1/6 times a 6 over 11. Okay, and now we do the multiplication. Multiplication's easy. 2 times 1 is 2. This 2 times 6, that's going to be a minus 12 over 11. Here we'll get a 1, just a 1/6, right, times 1 there. And here we're going to get, well, here the 6's will cancel out, so we just get a 1 over 11 here. Just like that, okay? And notice that these two terms already share a common denominator. So if I want to, I can just combine them right now. So let me do that. Let me rewrite this as 2. I'll say 2 plus 1/6 minus 13/11, right? So it's just negative 12 minus 1 is going to be my negative 13. Okay, so now what we need is a common denominator, right? And since the number 11 is already a prime number, I think I'm just going to have to multiply these two denominators together. So that's going to give me a common denominator of 66. Okay, so everything needs to have a denominator of 66, including this number 2. I'm going to think of that as a 2 over 1. Okay, so I'm going to multiply this by a 66 over a 66. This one here, let me move this over. I'm going to multiply this by 11 over 11 and this by 6 over 6. Okay, so that should get me everything in a common denominator. On this side, 66 times 2, what's that? 132, I believe. 132 over 66. Plus, this will just be 11 over 66. And this will be then minus, what's 6 times 13? Let me see real quick here. So this is going to be an 18. That'll be a 6 and a 7. 78. Okay, so that'll be a 78 here. 78 over 66. Okay, so now I just have to add and subtract everything here. So 132 plus 11, that's going to be 143. And I have to subtract a 78 here. Okay, so let's try and do this. Here I'm going to, let me grab this, a 13, that's going to be a 5. And this will be a 13 minus 7, so that'll give me a 6. So 65. Okay, so this will be a 65 over 66, and that is going to be my final answer right here. All right, so let's look at the next one. So here I'm going to have these compound fractions, right? So I can think of this as essentially 3 divided by 3/4. It can be 3/4 divided by 3. Okay, so how do I do this? I'm going to transform this division into multiplication, right? So I'm going to take this denominator and take it up and then multiply by the reciprocal, right? That's the idea here. So I'm going to use that idea of transforming 3 divided by 3/4, and I'm going to transform that into 3 times 4/3, right? Making the reciprocal there to change division into multiplication. So that's going to be my first term, and then I'm going to do the same thing over here. I can think of this as 3 over 1. So again, I can change this into a kind of multiplication. It'll be 3/4 multiplied by the reciprocal here, so that'll be 1 over 3. Okay, so that's how I can transform division into multiplication. And now things are pretty easy. We can see that these 3's are going to cancel out. So here I'm just going to get a 4. And over here, again, these 3's are going to cancel out, so I'm going to get a minus 1 over 4. So 4 minus 1 over 4. I need a common denominator. I'll just use 4. So to get a common denominator, I'll have to multiply this by 4. Oh, let me write that as 4 over 4. And remember, I'm thinking of this as 4 over 1, right? So this winds up becoming a 16 over 4 minus a 1 over 4. That's going to equal 15 over 4. And there we go. That's going to be our answer here. Let's go to the last practice problem. All right, so this one is another sort of compound fraction, and we've got an addition of fractions in the top and an addition of fractions in the denominator. So let's try and do those two additions first, and then we'll evaluate what that compound fraction becomes. So for the first one on the top here, I recognize we need a common denominator. But 2 is already a multiple of 6, so we can just use 6 as a common denominator here. And so to get this 2 into a 6, we'll just have to multiply by 3 over 3, right? And I think that's pretty straightforward, so let's see what that's going to give us. So this will be a 2/6 plus a 3 over 6, right? And so we can see this is, that's fairly straightforward. This will just become then a 5 over 6. Okay, so that's good there. Now let's evaluate this bottom part. Okay, so for this bottom part, again, we need a common denominator. But this one's a little bit more complicated. So let's use our prime factorization technique here. Let's get the prime factorization of 12 and 18. Okay, so 12 I can think of as 2 times 6. And that's going to be equal to 2 times 2 times 3. So I can condense that into 2 squared times 3. Okay. For 18, I can think of that as 2 times 9, which is going to be, well, this is going to be 2 times 3, which is then 2 times 3 squared. So we get a common denominator. Let's see what's missing. So this one, we're okay, the factors of 2 are enough, but we're missing a factor of 3. So we're going to have an extra factor of 3 here we have to multiply in. And this one, we're missing a factor of 2, aren't we? Okay, so we're going to add an extra factor of 2. The 3's are okay. That should be fine. So 12 times 3 is going to be 36. 18 times 2 is going to be 36. 36 is going to be our common denominator. So to get a 36 here, I have to multiply this by 3 over 3. And I have to multiply this by a 2 over 2, right? That's the idea. So let's do that multiplication now. Over here, 3 times 1 is just going to be 3. So 3 over 36 plus 2 times 3 is 6. So 6 over 36. 6 plus 3 is going to be a 9. So let's write this as 9 over 36, okay? Now let's see how we can evaluate this and maybe simplify. First, I recognize that 9 over 36, I can simplify that directly. Okay, so this will be equal to then 5 over 6 times, well, I can write this as 9 over 4 times 9, right? And so in that case, these 9s will cancel out. And what I'll be left with is just 1/4. Right, so I'm just going to write this as 1 over 4. And now I can take this and I can transform it into a kind of multiplication. This is going to be 5/6 multiplied by the reciprocal of the denominator, which is 4 over 1. Okay, and I can do some cancellation here. This will be a 2. This will be a 3. So finally, I should get 5 times 2. So that's going to be a 10 over 3. That should be my final answer. Okay, I do want to show you one other way that we could evaluate this problem here. So let me grab a copy. And the idea is, what I want to do is I recognize I have all 4 of these fractions. What if I find the least common denominator for all 4 of these smaller fractions from the very beginning, okay? So I want to get the least common denominator here. I have a 1/6, I have a 2, a 12, and an 18. And what I'm going to use is 36, okay? So I found that was the least common denominator for 12 and 18. And I see that 6 and 2 are already factors of 36. So I can use 36 as the least common denominator for all 4 of these fractions. So in order to do that, we already saw on the bottom, I'm going to have to multiply this by 3 over 3. This will be a 2 over 2. Now to get a 36 here, I'll have to multiply by 18, all right? So this will be an 18 over an 18, and here will be a 6 over 6, right? 6 times 6 is 36. Okay, so from here, let's evaluate what we get. So in the numerator, I'm going to get a 6 times 2 is a 12, plus 1 times 18 is 18, all over my common denominator of 36, and that is going to be all over a 3 times 1 is a 3, plus a 3 times 2 is a 6, and all of this is over, again, my common denominator of 36. And now here's where the magic happens. I can multiply this fraction by a 36 over a 36. I'm going to multiply sort of the big fraction by 36 over 36. And when I do that, I'm essentially multiplying this by 36, and I'm multiplying this by 36. So what happens is this 36 here is going to cancel with that. This 36 is going to cancel with that. So I eliminate sort of my compound fraction here. Now I can just write this as 12 plus 18, that's going to be 30 over 3 plus 6 is 9. Okay, so I've really simplified my fraction here. I've gotten rid of that denominator there. And I can simplify further, right? Because this is the same as 3 times 10 over 3 times 3. So this common factor of 3 will cancel out. And look what happens. That's 10 over 3. Very same answer. Okay, so hopefully this was a good practice using all of these properties of fractions to add, subtract, multiply, and divide them. Keep going until these properties are second nature.